Hello, and welcome to today's edition of Talking to a Biologist. Today I'm with Dr. Darren Gillis from the Department of Biological Sciences here at the University of Manitoba. Welcome, Darren.
Thank you.
So tell us a little bit about yourself. What first got you interested in biology when you were younger?
Well, I think I always spent a lot of time either on the beach or out in the woods, spent time fishing and those sorts of things. So it was a general interest I had, but it wasn't until I hit university that I realized I could combine that interest with some of my technical skills and turn it into a career.
So what area of research are you interested in, and what is your current research on?
My research area is in fisheries science, specifically what we call fleet dynamics, or the study of fishing effort, how that influences how we make ecological interpretations on what's going on in ocean ecosystems.
Wow, that's a mouthful. Can you tell us more about what that involves? We have lots and lots of computers here in your lab. How does one study fleet dynamics?
Well, first you need to get information on the fishing fleet. 20 years ago, you would do that by interviewing fishermen, by going to their logbook records, and that's how I got my start. But now we have much more information collected automatically and electronically, which allows us to ask more detailed questions far more easily. But it also requires bigger computers, so everything kind of scales up over time.
All right. So if you were talking to, and you are talking to first-year biology students, and they're interested in biology, but they're also interested in computers and sort of the dynamic side of that, what advice would you have for them?
Well, I would say to continue to develop your quantitative skills. A faculty member gave me advice when I was an undergraduate, and he said, if you're going to do biology, you need to be good at something else. And what he meant was chemistry or math, because unlike other sciences, biology is an integrated science. It takes information methods from other areas and applies them to our fundamental biological questions. In terms of ocean systems, most of our questions these days, or a lot of our questions, are pressing and quantitative in nature. We're interested in how many codfish are left, not whether or not that's a codfish. How many northern right whales do we have in the Bay of Fundy? Quantitative questions require quantitative answers, which is why I chose to develop quantitative skills.
So to answer some of those questions, how are we finding out whether or not we have how many cod left in Atlantic Canada, and whether or not there will ever be a cod fishery again? What sort of questions do we need to ask to answer that question for the policymakers?
A lot of our questions, whether we're talking about cod or whether we're talking about local fish populations in Manitoba, require better information. We have the quantitative tools. I have some of them in the lab around me, and we certainly have over a century of fisheries science, and Canada has always been a world leader in that area. What we have difficulty doing is often getting the data or the information required to say how many cod there are. So to give you an example, if you take a look at the Scotian Shelf, which is illustrated on the computer screen behind us here, that whole area is surveyed once a year for all fish species, one vessel over the course of 1 month. And that sounds like a lot, and it certainly costs a lot, but in terms of the area and the number of fish on the Scotian Shelf, it isn't really very much. So statistical methods have to be very carefully applied to make best use of the resources. And even so, you don't get the amount of information that you get if you integrate other data sources, and that's where my research comes in. Commercial vessels are out there all of the time, pretty much, catching something. So there's a wealth of information from the commercial fleet which has been collected for regulatory purposes but hasn't really been applied ecologically to the level that it could be. It is used in stock assessments, but it's only used once. I believe that there's much more information we can get out of it, and for the past 15, 20 years or so, I've been working with fisheries scientists who are doing those stock assessments to try to get more information and better information from the fisheries systems that they're already studying.
All right, that's very interesting. So if you could just follow up with a little bit on that, how does that fit in with someone here in landlocked Manitoba? I guess, pardon me, there is Hudson Bay.
Yes, there is Hudson Bay, but perhaps we don't have to go that far to see its relevance. If you go up to Lake Winnipeg, for example, we have a very lucrative commercial fishery and have traditionally in Manitoba for a long time. You could say it's a lake, you could say it's fresh water, but one of the commonalities it has with the marine systems that I also work on is, well, we're fishing. And human fishing methods are relatively similar among areas. The boats are a little smaller on Lake Winnipeg. There aren't as many different types of gear being used. But a lot of the principles that I apply on ocean systems apply equally well in the lake system. It's simply a question of getting the information to apply them.
All right. Well, thank you very much, Darren. Thank you very much for sharing your time with us. That concludes today's edition of Talking to a Biologist. Your regular lecture will begin now.